Here are the solutions for the Further Mathematics Written Examination 1 for VCAA 2021 for the Northern Hemisphere. Section A, Core, Data Analysis. Use the following information to answer questions 1 and 2. The histogram below shows the distribution of the mean number of years of schooling of women aged 65 years and older in 187 countries in 2015. Question 1 is asking for the percentage of these 187 countries where the mean number of years of schooling of women aged 65 years and older is less than 1 year. For this, we need to look at the first column in the histogram because this is less than 1 year. There are 43 countries in this column. Because we need to calculate the percentage, we calculate 43 out of 187 times 100, which is approximately equal to 23%. So the answer to this question is option B. In question 2, we are asked to determine the median of the mean number of years of schooling of women aged 65 years and older in these 187 countries. First of all, we need the histogram from the previous question. We know that the median is the value in the middle. Since there are 187 countries, divided by 2, that is equal to 93.5. In the first column, there are 43 countries. In the second column, there are 24 countries. In the third column, there are 12 countries. In the fourth column, there are 10 countries. And in the fifth column, there are 7 countries. Let's calculate the number of countries in the first 4 columns. That is 43 plus 24 plus 12 plus 10 equals 89 countries. So we are below the 93.5. And now if we add the 7 in the fifth column, that gives us 96, which means that the median is between 4 and 5. The only value that fits this interval is 4.4. So the answer to this question is option C. Question 3 is asking for the type of variables, number of family members, and age group 15 to 24 years, 25 to 34 years, and so on are. The first one is a definite numerical variable because it's the number of family members, which can be 1, 2, 3, and so on. The second variable, though, is an ordinal variable. These are intervals, and they are written in order. So the answer to this question is option C. Question 4. A class of 25 children in year 5, 15 girls and 10 boys, set for a mathematics test. The mean score on the test for the 15 girls in the class was 28.5. The mean score on the test for the 10 boys in the class was 25.5. The question is asking to calculate the mean score on the test for the whole class. For this, we are going to calculate the total number of scores for the girls, which is 28.5 times 15 equals 427.5. And now the same thing for the boys, that is 25.5 times 10, which is 255. We add up these two values, and that gives us 682.5, which is the total number of scores for the whole class. We divide this by 25 and we obtain a mean score of 27.3. So the answer to this question is option D. Question 5. The amount of salt in a salt container in grams is approximately normally distributed with a mean of 756 grams and a standard deviation of 2 grams. The question is asking for the number of containers in a random sample of 1,000 of these salt containers expected to contain less than 750 grams of salt. Let's start by drawing the curve for the normal distribution. The mean is 756 grams, and then we go by increments of 2 for the standard deviation to the left. So 754, 752, 750. Now this 750 represents 3 standard deviations to the left of the mean. Using the symmetry of this curve, we can mark the 3 standard deviations to the right of the mean. We know that 99.7% of the data is contained between 3 standard deviations to the left and 3 standard deviations to the right. We need to calculate the percentage of less than 750 grams, and that is 100 minus 99.7, all divided by 2, which is 0.15%. Remember that the question is asking for the number of containers in the random sample of 1,000. So 0.15% of 1,000 is equal to 1.5, which is approximately 2 containers. So the answer to this question is option B. Question 6. Ruth sells eggs. From past experience, Ruth knows that the mean weight of the eggs that she sells is 56 grams. 2.5% of the eggs that she sells have a weight that is greater than 65 grams. The question is asking for the standard deviation of the weights of the eggs, assuming that the weights of the eggs that Ruth sells are approximately normally distributed. So we know that the probability of W, so W is the variable weight, is greater than 65 is equal to 2.5%, or 0.025. We are going to change the variable W into the Z score. So probability of Z greater than 65 minus 56, all divided by sigma, where sigma is the standard deviation, is equal to 0.025. Using available case technology, we are going to calculate the inverse normal of 0.025 with a mean of 0 and a standard deviation of 1. And that is negative 1.95996. We can write the equation 65 minus 56 divided by the standard deviation equals negative 1.95996. If we solve this equation, the standard deviation sigma equals 4.59 grams. The answer that is closest to this value is option E, 4.5 grams. Question 7. A college awards a certificate of high achievement to a student if that student's score for a subject is in the top 10%. Ceci studied Mathematics A, Mathematics B, Physics, and Chemistry in her first year at the college. The mean and the standard deviation of student scores for these 4 subjects and Ceci's score for each of these subjects are shown in the table below. Assuming that the student's scores for each of these 4 subjects are normally distributed, the question is asking what is the number of certificates of high achievement that Ceci received. Let's see where Ceci's scores are. For Mathematics A, we calculate normal CDF from 80 to infinity when the mean is 69 and the standard deviation is 12. And that is 18%, which means that Ceci's score is in the top 18%. We are going to calculate the same for Mathematics B. Ceci's score is in the top 1.7% for this subject, so she's going to get 1 certificate here. And then we calculate the same for Physics, that is 17.8%, and then for Chemistry. And again, this is 1.7%, so this is another certificate of high achievement. So the answer to this question is option C, 2 certificates. Use the following information to answer questions 8 and 9. The blood pressure, normal and high, and the age group 60 to 69, 70 to 79, and 80 plus years of a group of people were recorded. The results are shown in the two-way frequency table below. Question 8 is asking for the percentage of people who have high blood pressure and are in the 70 to 79 years age group. The high blood pressure is in the last row, and 70 to 79 years of age is the column in the middle. At the intersection of these two, we have 37 people. Now, we need to calculate the total number of people, that is 80 plus 60 plus 40, which is 180. To calculate the percentage, we divide 37 by 180 times 100 equals 20.56, approximately equal to 21%. So the answer we are after is option A. In question 9, we are asked to determine the percentage of people in the 60 to 69 years age group who have normal blood pressure. For this, we are going to look at the first row for normal blood pressure and the first column, 60 to 69 years of age. At the intersection of these two, we have 42 people out of 80. 80 because it says the percentage of people in the 60 to 69 years age. We multiply this by 100 and that is approximately 53%. So the answer we are after is option E. Use the following information to answer questions 10 and 11. Bone length in millimeters of one of the metacarpal bones and height in centimeters were recorded for a sample of 9 people. The results are shown in the table below. Question 10 is asking for the mean and standard deviation of bone length for this sample of 9 people in millimeters. For this, we are going to enter the data in a spreadsheet on the CASE technology available. On a TI Inspire, we use menu, 4 statistics, 1 stat calculations, 1 variable statistics, and then we choose bone length as the variable. So the mean is 45.4 and the standard deviation is approximately 3.88. So the answer we are after is option B. In question 11, we are asked for the equation of the least squares line that enables bone length to be predicted from height. For this, we already have the data entered in the spreadsheet. On TI Inspire, we use menu, 4 statistics, 1 stat calculations, and then 4 linear regression A plus BX. We choose height for the X variable and bone length for the Y variable. And the equation we are after is the equation from option A, bone length equals negative 28.6 plus 0.431 times height. Question 12. A least squares line is used to model the association between arm span in centimeters and height in centimeters as well. With the values of the y-intercept and slope left unrounded, the equation of the least squares line is shown below. The question is asking to round the numerical values to 5 significant figures. The first number is going to be negative 67.680, that's 5 digits, and the slope is going to be 1.3558. So the answer we are after is option B. Use the following information to answer questions 13 and 14. The table below shows the mean life expectancy in years and the per capita income in dollars for 13 countries. A scatter plot displaying this data is also shown. Question 13. A login base 10 transformation applied to the variable income can be used to linearize the scatter plot to determine the equation of the least squares line fitted to the linearized data if we use login base 10 of income as the explanatory variable. For this, we are going to enter the data in a spreadsheet on available case technology. The first column is going to be income, the second column life expectancy, and the third column is going to be login base 10 of income. Then, on a TI Inspire, we use menu, 4 statistics, 1 state calculations, 4 linear regression, A plus BX. We choose login base 10 of income for the X variable and life expectancy for the Y variable. And here are the values that we need. So the life expectancy equals 32.35 plus 10.32 times login base 10 of income. So the answer we are after is option E. Question 14. The scatter plot on page 9 can also be linearized using a square transformation applied to the variable life expectancy. The equation of the least squares line for this linearized data is shown below. The question is asking to calculate the life expectancy when this equation is used to predict life expectancy in years for a country with a per capita income of $20,000. So we use the equation given, life expectancy equals square root of 4,801.6 plus 0.04715 times 20,000, and that is approximately 76 years. So the answer we are after is option D. Question 15. The seasonal index for the number of cars sold at a local car dealership in June is 0.8. To correct the June car sales for seasonality, the actual number of cars sold should be increased or decreased, and by how much? We are going to start from the formula. The seasonalized value equals the actual value divided by the seasonal index. So in this case, the actual value is divided by 0.8, which is the seasonal index for June. We are going to separate these two values, so we have 1 over 0.8 times the actual value. If we divide 1 by 0.8, that gives us 1.25 times the actual value, which means that the actual number of cars sold should be increased by 25%. So the answer for this question is option D. Question 16. The table below shows the monthly rainfall in millimeters recorded at a weather station over a 1-year period. The question is asking for the 6 mean smooth monthly rainfall with centering for May in millimeters. We are going to start by calculating the mean of the months February, March, April, May, June, and July. So we add up all those values, divide by 6, and the mean is 93.23. We do the same for the months March, April, May, June, July, and August. So we add up all those values and again divide by 6, and that is 100.87. For centering, we are going to add up these two values and divide by 2. And that is approximately 97.1. So the answer we're after is option B.